children, if we look at, there's probably a good reason to call the scatter plot, Maggie Dervis. Why do you suppose they call those scatter plots? Because the lines and the stuff is all scattered about, and that is exactly it. And what to deal with scatter plots basically is this. Sometimes when you do data, look in your books on page 538 and 539. Sometime when you look at data and stuff that you have, it doesn't always fit into a nice, neat little line or whatever. For example, here'd be a good thing that you can make a scatter plot of. If I took a survey of you and asked you how long you studied for your last math test, and I made a scatter plot here. You don't have to write this down. Just listen for a little bit. Okay? And this was the time you spent studying, and this was the number of problems you got wrong. Like 1 problem, 2 problems, 3 problems, 4 problems, 5 problems. Okay, is there a correlation between how much time you study and probably your grade? Yes, there probably is, right? Let's say you studied, let's say this is number of minutes. Let's say this is 10 minutes, 20 minutes, 30 minutes, 40 minutes. 1 problem wrong, 2 problem wrong, 3 problem wrong, 4 problem wrong, 5 problem wrong. You could have somebody that spends 10 minutes studying and gets, what, how many wrong? Like 3 wrong. Okay, but somebody else could spend 10 minutes studying and get only 1 wrong. Okay, those dots aren't probably gonna, it's not gonna make a nice even line, but probably the more time you study, what's going to happen? You're gonna get more problems right or wrong, more problems wrong or fewer problems wrong. Usually the more time you spend studying, you're going to get, if you spend 40 minutes studying, you're probably going to get fewer problems wrong. The least amount of time you spend studying, you're probably going to get more problems wrong. And these dots are probably, when you graph this, going to follow a pattern. Okay, and that's what this is here. There's 3 things that are going to happen with scatter plots. Okay, either you're going to look at them and it looks like that the line, these dots kind of follow a pattern where it goes up from left to right. Okay, that is what we call a positive correlation. I'm going to highlight that. Okay. If the dots look like they're falling down, okay, that would be a negative correlation. That's example number 2. And the third thing is, sometimes when you do a scatter plot, they're not going to have any correlation at all. For example, age and shoe size. Okay? Age and shoe size probably does have some correlation up until you get to be about, 10, 12, 14 years old. But, your parents' shoe size has probably remained the same for the last 25 years that they've been alive, so there's not going to be a correlation there because it stays the same. Sometimes when you do a scatter plot, there's going to be 0 correlation, which means the dots, you look at them and you go, they're just all over the place. There's no way that I see any resemblance there. Okay? Now with that being said, children, I can tell you're very excited about this. Okay, we are going to talk about a line of best fit. Okay, and what that means is, and this is one of those things that is not a completely exact science. Okay, these are ones where you can only get so close and you have to call it good enough, but at least you need to be able to get it close enough. If you look at these 3 different scatter plots, okay, what is this?
Right.
Oh, I heard you. Did I not get it to him?
No.
It's like that Villanova shot last night. Guess who picked Villanova to win it all? I did. Somehow, I think we need some practice. Ready? Yes. Okay. What line of best fit means is this, and this is something you're going to do with a straight edge if you have the ability to and have a straight edge. Okay, this means that what you do is you look at the dots that make, first of all, positive or negative correlation. negative correlation, stuff goes downhill. You need to take your ruler and try to draw a line through those dots, which kind of splits everything down the middle and makes it kind of even. In other words, I'm going to take my ruler, I'm going to draw a line, and I want to try to get it in the middle of all that, so that it kind of, it's called the line of best fit. It doesn't say it's the line of exact fit. Would you say that that is the best place to draw that line? Oh, come on, no. Why? What would I change if I were doing this? See all these dots over here, and the few dots that are up there? I would adjust this line so that it is more like this. Okay, see how now more of those dots? And you can only get so good, but you want to have about the same number of dots below as above, and maybe I would move this one up here. Maybe even a little bit more, I don't know. Okay, again, you can only get so good at it, and then you just call it good enough. But you really want to have it, I mean, this one's going to be a lot easier to do because it forms much more of a straight line. This one you're, and then when you do that line, people, okay, take a look at what the data is. This is driver's age in years and their ability to see the distance. Okay, driver's age in years and how far, you know, sign, how far away they can read a sign. And typically, as people get into their 80s, they lose their vision, so they can't see quite as well. Usually, you young kids that are like 15, you know, you're going to be able to see whatever. You know, you do this line of best fit because if somebody said, well, if you're the age of Mr. Han, who's the old person here, at 48 years old, how far should I be able to see a sign away from me? Well, so you find 48 years old, which is right about here, and go straight up from there, and you look where that line would cross over here, and you would, I mean, again, it's not an exact science, but it looks like it would cross somewhere here, and you could say, well, Mr. Han should be able to see about what, 400 and, I don't know, 10 feet or whatever, 415 or something like that. Okay, so you can make some predictions based on your line of best fit. You guys are not quite 15 years old, so at 15 years old, you know, you should probably see somewhere up there at how many feet? Maybe that's what, 530 feet? You can kind of guess there. How far would you say a 65-year-old man should be able to see, or a 65-year-old person should be able to see? Well, you go up from 65 years, and it looks like it falls somewhere in here, probably, you know, or you could predict at 90 years old, which you probably shouldn't be on the road too much longer after that, you know, you're going to be down here in that level right there. Okay, so that's line of best fit. This one here is going to be a little easier to do because the lines kind of form, the dots kind of form more of a line right there. If you're going to draw a line, does that look pretty reasonable? I mean, I would say maybe yes, maybe the top could be down a little bit. It really would be hard for me to mark you wrong unless it was a glaring, obvious sort of thing. Maybe the bottom should be up a little bit. Okay. And in addition to that, people, well, we talked slope-intercept form of linear equations? Yeah. Okay. Realistically, you should be able to look at this line and you should be able to tell me what its equation would be close to. And again, it's going to be a little different for everybody because it depends on you do. Y equals mx plus b, if you remember our linear equation. The letter b is where it crosses the y-axis, which if you look at this one, what would you guess? It crosses the y-axis at about what? Take a stab at it. Claire? About what? I would go, that's not bad. I'd say about 135. It's not quite up to 150. So, and then what is the slope of that line? That's going to be a little tougher to figure out. How would you figure that out? You need to, remember, make a triangle. Find a place where it crosses. Let's say this is your triangle. How high is my triangle? From here to here is how many? From 200 to 400 is how far? 200 high. How wide is it? From 12 to 18 is how much? To go from 12 to 18, you'd have to go up how much? 6. So this, it would be 200 over 6x, which reduces down to what? Maybe 100 over 3. And it's not pretty, but you could write that equation of the line so that you actually have something kind of close there. I don't even know what this is about, but, you know, if I were asking you to predict at, you know, 20 years of age, how much, or 20 degrees Celsius, how many dollars would it take for you to do something or whatever? Go up straight here from 20. What's that say? How about how much money? Alex?
450.
Yeah, about 450. And then let's look at even this last one here. Let's make it big so you can actually see it. What is that? Dollars and ages. I have no idea what that means. What do you think it could be?
How much money it makes?
Oh, 1-year-old makes $10,000 when a 10-year-old is going to make 1,000.
That's how much they own years.
How many years? What?
Years.
How many years? They said no. This is dollars and this is years.
How much is it?
Age of somebody. If you're drawing the line of best fit, then you kind of do what? You're going to try to split this down the middle. And remember, something to keep in mind when you do this, you know, if you see a random dot that doesn't seem to fit in the pattern, it's kind of all by itself, don't even really count it. You just kind of completely ignore it. I would probably what? If you were going to adjust this line, what would you do? Anybody? You can criticize me. Logan?
Maybe put it up a little bit.
Yeah, I would certainly think you could go up a little bit with this side over here. I don't know, that maybe isn't too bad, maybe just a touch bit more. Okay. I don't know, maybe that's too high now. But again, it's not an exact science, the teacher's not going to be able to count it wrong unless you do something like this. I mean, obviously, I go, you know, that's kind of way off there. That would be. And then you're going to predict from there, write an equation, positive correlation, negative correlation, negative going downhill correlation there. Perfect. So, you're going to go to the laboratory. Let me stop this.